Super. Okay, so let me get arranged here. Where to begin? Okay, so thank you to those of you who filled out the survey at the end of last week. Once again, we try to use as much of that feedback as we can as we do lesson planning for the following weeks. So we are going to try to give you all a lot more time for working independently and then among your great breakout rooms too during the challenges, because it sounds like people have really valued that time. And we're also going to start just pasting those challenges in the chat so that you don't have to keep navigating around stuff. So this week we asked you, or last week I guess, we asked you to just do part 1 of that week 4 homework assignment because we didn't get to start with any Tidyverse stuff yet. But before we go over the homework, I'd like to make sure everybody has installed Tidyverse. So if you have gone through that process, can you put up a green sticky? And if you have not done that or don't know if you've done it, can you put up a red sticky and we'll get a TA to help you out with that while we go over the homework? All right, it looks like, wow, looks like everybody did it. Awesome. Thank you all for doing that because I know that is kind of a big ask to do independently. But that's great. So we can jump right into that once we finish going over the homework. So I'm going to share my screen here. And I believe that you should now be seeing my RStudio screen. Looks like I'm getting some thumbs up. Okay, so for the homework, what did we ask you to do? We asked you to import the portal data joined data set like we used in class, and subset that data set to include only several columns and several rows. So would somebody like to walk me through what their approach to homework 1 was?
All right, I'll do it. So for homework 1, you meant the first question of homework 4.
Sorry,
right?
yes.
Yeah, okay. So I read in the survey with read.csv, just like we had during class. And then I automatically just did read.csv and then what it was called, the relative file path, then comma, strings as factors equals false, because I read in your instructions that we were going to change things to characters anyways. And then I created a new vector or data frame called surveys_base, and then did indexing. So surveys with the big brackets, 1:60, comma, concatenate, parentheses 6, 9, 13, and then ran that for the first part.
Wow. That was a lot of indexing all at once. So let's take a look at this surveys base and see what Logan came up with. It looks like we have species ID, weight, and plot type, which, if I remember, those are the columns that we wanted. And we have 60 rows. Okay. Logan, did you do anything else?
I did, but I didn't.
Okay.
I can keep talking if someone else doesn't want to.
Yeah, that would be great to have somebody else speak up.
I have a question, not a solution.
Yeah. Okay.
Why can't, to select the columns, why can't you use the column names?
You can, I believe. Did you try that and have problems? Yes. Okay. Can you walk me through how you tried it?
I said, let me look. I said surveys base and then reassigned it to surveys. Sorry, I'm bad at explaining this. So I said
that's fine.
surveys base and then survey space again, and then I said in what are they called, brackets, species ID, comma, weight, comma, plot type, and it failed.
Okay. So that is a good start, and you can index using like character vectors with column names, but there's a really particular way that you need to do it. So in this case, remember that R likes to go rows before the comma in indexing and then columns after. So we could use Logan's 1 through 60 again. And then after the comma, we would need to include all of those column names in a concatenated vector. So we could do it like this. ID, weight, and plot type. And this should give us the same answer as surveys base 1. And one way that we can check that is there's this function in R called all equal. And let's just see if they're the same. And they're all the same. So you can use column names, you just have to make sure that you do it after the comma and that they're all together in this concatenated vector.
Okay, yeah, that's what I was missing. Thanks.
So the next thing that we needed to do was get rid of those NA weights. Did anybody come up with a solution for how to do that?
I did. So I created a separate object from surveys base. So I called it surveys base underscore NA. So surveys base underscore NA arrow, surveys base, the brackets, complete cases, and then in parentheses, surveys base, comma, and then a space. Oh,
so you had a
yeah.
comma after the parentheses?
That's correct. Yeah.
Okay, so this is a way that worked because of how these data are currently structured. And so this got rid of all of the, let's look at it. This should have gotten rid of all the cases where there were NAs in the weight column, but one thing to be aware of is that complete cases will look across all of your rows. So if you had an NA in species ID, but a value in the weight column for a particular row, complete cases would also get rid of that row. So just be really careful when you use complete cases because it can sort of look at more things than you are necessarily expecting it to.
Would you be able to use complete cases and then do surveys base $, and then the column that you're trying to remove NA values from? Would that work? Or no?
Let's give it a shot and see. Yes, so that still returns the correct answer, and I'm betting that because we specified weight, it's only looking at, yeah, just that column of weight stuff.
Okay, cool.
What does the $sign do?
Oh, that's a good question. The $sign is one way to point R to a column in a data frame. So you can use the $sign and then the name of a column, or you could also use another set of indexing brackets and put this in quotes and after a comma because it's the column. And that is, once again, the same thing. So I can make a note on the live code about this. And we can check if these are equal. And, interesting. So in cases where there were NA values in the weight column, we actually can't check if those are equal. Wow. So then the question becomes, does NA equal NA? And the answer is NA. So that solves that, sort of. Okay.
Could they be different types of NAs? Like a character NA versus a number NA?
Let's
Because
see.
weight would be numbers, and then the other ones are probably characters, right?
That still returns just an NA value, whereas if I tried comparing within the same type, it still returns an NA value. But that was a great question as well. Okay, and then we also asked you to, let's see, create another data frame that is called challenge base, which only includes individuals with a weight greater than 150. And for the sake of time, I'm just going to blow through this quick. Subset weight greater than 150, and we can call that challenge base equals surveys base NA, in which surveys base NA is greater than 150, and then a comma to indicate that we're interested in rows where surveys base NA by weight is greater than 150. And we can look at that, and now we have a smaller data set with just these individuals that have a large weight. Does anybody have any questions on the homework before we move through into some Tidyverse stuff? Okay, so we are going to now begin with a brand new sort of philosophy in the R world. And this is a very different way of thinking about the structure of data and how we communicate with R about data. And something you're going to realize during class, and it might initially be frustrating to you, is that we're going to learn today how to do the exact same stuff we did last week using a different technique. And the reason we're showing you both is because a lot, especially older people, tend to use the so-called base R, which is what we've been using with these indexing brackets and dollar signs and stuff. The Tidyverse is a young people's approach. And you will see, if you're on Twitter, people love the Tidyverse. If you take an R class that's taught by like one of the older people at the Data Science Institute or something, you might end up seeing a lot more base R, and like professors that teach stat classes are often using base R as well. So a few things to fill you in on before we get started. First of all, you might notice that oftentimes when Liza and I are live coding, we use this, we can use a hashtag to indicate that we're making comments, but you can also start so-called chapters in RStudio. And so let's call it into the Tidyverse because that is fun and Spider-Verse related. We can use 4 hashtags and then 4 dashes or 4 underscores or whatever you want afterwards. And that starts a new so-called chapter. And you'll see down here in this little, the bottom of my actual script panel, you can see it has these different chapters that I've already set up. And you can jump to them as you are working through your code. So it's kind of a nice way of piecing apart or breaking up your code. Okay, so today we're going to be talking about the Tidyverse, and you have all installed it, but I would imagine that a number of you at least don't really know what you installed or where it went or what it means. And so the first thing we need to understand before we start playing around with new so-called packages is what a package is. And you will often see people people will refer to one thing as a package or a library, and those two words are used interchangeably. They're technically not exactly the same thing, but for the vast majority of cases where you're talking to somebody about a package or a library, you're talking about the same thing. And you can sort of think about these as, you know, at the Shields Library, well, you're all first year, so you haven't been into the UC Davis library yet, but a lot of university libraries have like a biology library and a law library and et cetera, et cetera, et cetera. And a library is like a place that you go to get a certain type of information. And in R, we have sort of a similar concept where a library is, oh, it looks like we're getting a lot of comments in the chat. Do I need to take a break here?
No, we're just chatting.
Okay, cool. Chat away. A library in R is sort of a cohesive package of functions that all have a similar goal in mind, or like they kind of are functions to a theme. So when we use this so-called Tidyverse package or library, it's actually a series of libraries that are all dedicated to making data tidy, usable, and understandable. And there are also libraries for downloading satellite data, and there are libraries for weird random statistical methods that you need to use, and there are libraries for making pretty maps. And like, if you can think of something to do with R, there's probably already a library out there for it. So the first thing I want to do is kind of explain how to understand like what you're dealing with libraries. So can people see my Google Chrome empty browser right now? Yeah, okay. Oftentimes libraries are stored on this website called CRAN, which is the Comprehensive R Archive Network. And when you used install.packages tidyverse last week or this week, your computer, when it was interacting with R, understood I need to look to this website to find a package called Tidyverse. So if we Google CRAN Tidyverse, the first thing that comes up is this CRAN website and its Tidyverse page. And so we can go to that, and it immediately looks super intimidating. There's like this code style font up here, and there's version, and then there's all these imports, and it is a lot to take in and is probably pretty overwhelming for a lot of people. But this is like the base page for everything to do with whatever library you're talking about. So in this case, we're talking about the Tidyverse, and a few things that you're probably particularly interested in for one of these home pages for a package is the reference manual. And so we can navigate to this reference manual, and it repeats a lot of the information that we saw on that last website, but it has the little description, and then it tells you all of the stuff that Tidyverse deals with. And Tidyverse is kind of unique because it's basically an umbrella package for a bunch of other sub packages. So I want to take you to a more specific one, like let's go to ggplot. And ggplot is like a way of graphing. And so we can go to the reference manual for ggplot, and we'll see it has this long table of contents here. And each of these entries is a single function in the ggplot library. So when you import the Tidyverse, you're also importing the ggplot library and all of the functions that it houses. Let's see, what else should I mention with packages? Okay, I'm gonna go ahead and import the Tidyverse package because we're gonna get some messages that we need to take a look at. So hopefully you're all actively coding as we talk about this, because ideally you will also import the Tidyverse, and we will see what it gives us. So if we want to import a package or a library, we need to use this library function. And you can see already R is trying to point me to different packages that I've imported in the past. And I can probably type TI, and it's already saying, hey, Tidyverse is one of those. So we can use library Tidyverse to import our package. And you can see here, I got a bunch of messages. As I mentioned, Tidyverse is sort of this umbrella package that includes a bunch of tidy libraries within it. And that is this first attaching packages message that we're getting. So when we imported Tidyverse, we actually imported ggplot, tibble, tidyr, readr, per, dplyr, stringer, and 4cats. the next thing that's really important to notice here is this conflicts line. And you'll notice it says dplyr : filter masks stats : filter. And what this is telling us is that before we had imported the library Tidyverse, there was already a function in base R called filter. So let's take a look at that one. And we can see in the help tab over here, the filter function in the base R stats library applies linear filtering to a univariate time series or to each series separately of a multivariate time series. I'm not sure exactly what that means, but it's important because it does a different thing than what dplyr's filter does. So dplyr is one of those libraries that lives in the Tidyverse, and you can point to a specific function in a specific library by using that double colon sign. So if I use dplyr and then : filter, let's take a look at what that does. This says, use filter to choose rows or cases where conditions are true. Unlike base subsetting with bracketing index, comma, rows, where the condition evaluates to NA are dropped. I think there's a grammatical issue with that. But, yep. So yeah, what I was trying to illustrate there is that there can be multiple different functions that have the same name, just in different libraries. And it's important that you know which function is the default for you when you are actually using R. So once we imported Tidyverse, you can say it's dplyr filter masks stats filter. And that means that from here on out, if we just say filter, R thinks that we're using the dplyr one because it's masking the base stats one. Are there any questions on startup messages for libraries? Okay, super. So let me reroute all my screens here quick. Okay, so last week, and in the homework assignment for the first section of last week, we used, where is it, this read.csv function, and that is built into R. So you can open up R and not load any libraries or anything, and R already knows that read.csv is a function for importing a CSV file. Well, Tidyverse has its own version of read.csv. So we can import data with the Tidyverse using a function called read_CSV. They're very similar functions, but they do slightly different things, as we'll see here in a second. So I'm going to make a object called surveys, because I used survey last time. And rather than read.csv, I'm going to use the read_CSV. And we'll point to the file in the same way that we did before, using quotations and then this relative file path within our directory to say we want to look into the data subdirectory and find portal data joint.csv. And when I run that, you can immediately see there's a ton of information that popped up, which we didn't get when I used read.csv. And so this is parsed with column specification, and then columns, and then all of the different column names, and it immediately tells us what class each of these columns is. So record ID looks like it's some sort of a number, whereas species ID is some sort of a character vector. And if we type surveys and just look at the object, we'll see it doesn't look exactly like what the product of read.csv was. You can see it says a tibble, 34,786 by 13. And so this is a slightly different format for storing data in tabular format, and it's kind of specific to the Tidyverse. And so it's telling us there's 34 some odd thousand rows and 13 columns, and it automatically only shows us the top 10 rows. And then it says with 34 some odd thousand more rows, and 4 more variables because this screen didn't have room for it to show us the column for genus and species and taxa and plot type. So let's see what we need to do with this. Okay, we can look at the class of surveys to see differences in the object type. And we see that there's actually 4 answers when we use this class function, and data.frame is but one of them. If we used cals class of simply survey, which was the read.csv style, we can see it only gives us a data frame. So when we import something using the Tidyverse, there's a bunch more information that R is kind of maintaining around the shape of this data and how it's structured so that it can expedite other processes that we might want to do down the line. Okay, so that's kind of takes us to approximately the end of that one lesson that we had hoped to finish last week, starting with data in R. And now we're going to move on to the dplyr and tidyr lesson under the course materials. So we've already imported our data, and we can look at it using class. I'm going to also make a note here, read_CSV style. We can also look at our data set using that structure function we talked about a couple weeks ago. This is one of my favorite ways of sort of previewing data. I use structure for just about everything I import. Almost every object I create, I'm always using str and then whatever the object is. Comes in super handy. So here we can see the structure of surveys is there's this, I don't know if this stands for special Tibble data frame or something like that. And then there's the Tibble data frame, and then there's Tibble in the data frame. And we can see sort of this first sort of, what's it called? Spit out. R initially gives us this little breakdown of what each of our columns are with this $sign that we just talked about a couple seconds ago. And then the data type and a preview of what lives inside that column. But then it also gives us this special line with some more information on what the column types are. And now finally we can get to some really exciting things that are really sort of repeats of last week, but you'll find I bet in 20 minutes you'll realize very quickly why this is a superior way of dealing with data, in my opinion. I think you'll agree with me. So last week we used these weird indexing brackets to point out rows and columns, and they're separated by commas. And you can see just in our going through the homework together, things get really messy really quick. They can be hard to look at. Things aren't super readable. Tidyr changes, or the Tidyverse changes a lot of that. So the first function that we're going to talk about from the Tidyverse is select. Select, as we can see here in the little yellow pop-out, select is choose or rename variables from a tibble. Select keeps only the variables you mention. Rename keeps all variables. So rename is a different function that we're not going to deal with today. We might talk about it later in the quarter, but for now, we will stick with select. And you can see the first argument that select expects to get is something called .data. And that's kind of a weird way of pointing to something we've never seen arguments start with periods before. But what we can see here is .data should be a tibble. And then there's ellipses after .data, and we can see one or more unquoted expressions separated by commas. There's a ton of more information in here in help documents, so I would encourage you to check it out. But what's important is that we're talking about one or more unquoted expressions, and in this case, expressions refers to column names. So let's say we want to, from our surveys data set, select just the stuff that we selected in the homework assignment. So the first thing is this argument called .data, and it needs to be a tibble. So we can give it surveys as our first argument, and then I like to separate arguments by lines because it helps me read things easier. So once we've told select what data set we're talking about, we can point it to specific columns. So let's try plot ID and weight, and what else did we have up here? Species ID. Oh, plot type. Well, we'll just do plot ID, weight, and species ID. And let's see what it gives us. Okay, so this is a 35,000 row tibble that has a bunch of NAs and weight. It has a column for plot ID, weight, and species ID, and only those three. So we have, of the surveys data set, we've selected just 3 columns. And that is, in my opinion, a much easier way to select data sets because it's pretty self-explanatory. You're saying select from this data these columns. We can also use a function called filter on the same data set. And this will perform a similar action, but with rows. And so we can say from surveys, we're only interested in data that came from, we'll say, the year 1995. And remember, when we're testing a logical question, so that is, does the year equal 1995 or not, we need to use 2 equal signs. So if we use filter surveys, comma, year equals 1995, we'll see we have all 13 columns are preserved, but now we only have about 1,000 observations, and they all come from instances where the year column equals 1995. We can do a bunch of funky stuff with this too, like say, filter surveys year is greater than 2000. And once again, this is a logical test of whether year is greater than 2000 or not. And let's see, these are pretty complementary functions. So before I move on to data pipes, does anyone have questions on the tidyverse, select, or filter? Okay, super. So this next step, oh, go
Sorry
ahead.
to interrupt. Monica had a question in the chat. I don't know if she wants to just ask it out loud or someone could read it.
I can just read it out loud. Thank you, Monica. This is a great question. Do you have to assign these filters to a new data set name the way we have done before using the assignment arrow? And it depends on what your goal is. So if you just want to look at something, you don't need to assign it to anything new. You can simply run the filter or select functions, and it will spit something out in the console. But if you want to preserve the result of this and be able to then work with it or look at it more closely, then you would need to use the assignment arrow. So we could say surveys 95 is filter of surveys year equals 1995. And now you can see up here in our environment, we have an object called surveys 95, and it has 1,100 observations of 13 variables. And we can do things with it like we did before to say command click or control click on the object to open it up in a new tab. And then we can look at this whole thing that is just the surveys data in which year is 1995. So if you want to make a new object, you can use the assignment arrow. If you just want to get an idea of what's going on and run a line of code to see what the result is, you can do it without the assignment arrow. Did that answer your question, Monica? Super. Were there any other questions before we move on? All right, great. So the next thing we want to talk about is pipes. And I found pipes to be very intimidating when I first learned about them because I didn't have like a formal R class, and everything that I knew about R, especially early on, was just in stuff that I Googled. And one day I was in a stat class and this person sitting next to me was like showing me these awesome data pipelines that she had built. And I was like, I don't really know what that means. This is your opportunity to know what that means. So if you have a series of actions that you want to perform on a data set, you can use what's called a pipe. And basically a pipe allows you to feed the result of one evaluation into a new function. And so, for example, let's say we have surveys. And we can look at that just like we did before, and it gives us the top, I mean, it shows us the top 10 rows, but it's really a tibble with almost 35,000 rows. And we want to filter surveys like we did up here to just include the year 1995. Rather than using filter and then put surveys inside of it, like this, we could instead feed surveys into a so-called pipe, and it would then pass surveys to the first argument of the function that comes after the pipe. And that sounds like a lot, but I think you're going to see here what I'm talking about. So a pipe is indicated to R using this % greater than % formatting. And I know it's sort of weird. I think there's a shortcut for it. Is it Command-Shift-M? Yeah, so on MacBook, it's Command-Shift-M, and on PC, it's probably Control-Shift-M. I often just type % greater than %, but you can use shortcuts if you so desire. And so once we have told R that we're going to pipe surveys into something, we need something for it to be piped into. So we want to use this filter function. And this is where that .data part becomes important. The Tidyverse is kind of built with these data pipelines in mind. And so it understands the first argument could be the product of a data pipeline. And so in this case, filter knows that we're going to be filtering surveys. And so rather than typing this full filter surveys here, instead we can type surveys and then a pipe and then filter and specify the year equals 1995. And we get the same result as we created above when we said filter surveys, comma, enter year 1995. And you might be wondering, why is this better? And I'm going to write some comments so that people following along in the live code can deal with it, because I know there's a lot of text here. So just give me 1 second. The reason that this is really nice is because rather than creating a surveys 95 object, which we then select from because we only care about 3 columns or something, we can take this and then again build another pipe that passes that whole thing straight into a select argument or select function, for example. And maybe we're interested in plot ID and species ID and sex. Now what we end up with is that same number of rows as before, but only the 3 columns we were interested in. So you can see how piping allows you to start off with just one data set and then do a series of filters and selects to sort of narrow down onto what you want. I think that this leaves us with, let's see, it was mutate before or after the challenge? Mutate is after the challenge. So next, we have a challenge for you. Are there any questions before we introduce the challenge? I know piping is kind of strange. Okay. All right, so the challenge we have for you is using pipes, subset the survey's data to include individuals collected before 1995 and retain only the columns year, sex, and weight, and rename this, or name this new data frame surveys challenge. So it's 250. Why don't you work on this alone for, what did we say, Liza? Alone for
I think
2 minutes.
2 minutes.
And then we'll go ahead.
I'll say this is a kind of a shorter one, but yeah, then send people into rooms and let them chat about it.
Okay, yeah, so work alone for 2 minutes. See if you can figure out how to filter and select columns. And the real challenge here is how to name the new data set surveys challenge. So take 2 minutes and then we'll send you into a little group setting and we can reconvene and see how you did. All right, Christine, do you want to send people into breakout rooms? Or I guess, am I able to do that or is that just a host TA thing?
I've got it on my screen. I can do it.
Okay, thanks.
So I just snuck into a breakout room to see if there was like a flagging option.
Okay, so it looks like we are all reconvened. Let's take a minute to go over the challenge as a group, and then we can take a little break. So what did we ask you to do? Where's my chat? Here we are. Okay, so the challenge was using pipes, subset the survey's data to include individuals collected before 95 and retain only the columns year, sex, and weight. Name this data frame surveys challenge. Can someone who has not told me what they did for homework explain what they did for the challenge? Go ahead.
I can talk if nobody else wants to. So I pretty much just named it like I usually name things, or like surveys underscore challenge, and then the arrow, and then surveys percentage greater than percentage, and then you add the filter that it's, less than 1995, and then select for year, sex, and weight.
Wow, that is perfect. What did we want? Year, sex, and weight?
Yes, I believe so.
All right, let's take a look. Surveys challenge. Cool. We ended up with a 21,000 row tibble with year, sex, and weight. And we can see in these first couple of rows, the year is 1977 or 78. We can also check and say maximum of surveys challenge by year. And we see 1994 is the largest number in that column from the product of the surveys challenge. Did anybody do anything different for that? All right, sweet. Thank you, Sierra. I think that about wraps up the first half of class. So let's take a nice 10-minute break, go stretch your legs, get a drink, go to the bathroom, look at some memes, and we will reconvene at 3:10. Thank you, everybody.
I want to stay here if there's music. Hmm. Hey,
Liza,
Connor.
did you see that comment?
Someone's breakout room had a porcupine, which is clearly awesome. And I want to know more about that, but maybe at the end of class. So, all right, welcome back to part 2 of class today. I also want to say, I know that like polls are closing and it's really tempting to just be like refreshing your maybe news source that's open on your computer. But this lesson today, at least for me, is like the most memorable of all the R. Davis classes because it is the stuff that like I use day in and day out for organizing data. And so if you're feeling like your mind is wandering, totally fine, you know, do whatever you need to do this afternoon, but also I think it's an exciting lesson to be paying attention to. So we're going to jump right back into learning more about this whole piping process and what the Tidyverse and sort of dplyr and all the affiliated functions can do for you. So I should share my screen. All right, and we have an RStudio screen, I think. And I'll move people around. Okay, RStudio screen, yes? Thumbs up. Okay, cool. All right, so we're gonna jump right into kind of some additional things that we can do in the Tidyverse. And one of the first things that we're gonna talk about is making new columns with the mutate function. Something else that's nice about the Tidyverse is that often their function names are pretty intuitive. Mutate is a little weird to me, but right, mutate pretty much means you want to change some column and create a new one.
Hey, Liza.
So, yeah.
Can you zoom in your RStudio a little bit?
Great reminder that we just talked about. Cool. So now hopefully that's a little easier for everyone to see. I know that sometimes it can be tough. So note that I'm going to try to like walk through this piping logic every time, but also this is something you'll just have to get a little more used to. And if I move fast or too fast, let me know. But I'll be using these pipes pretty intuitively at this point. So let's say we want to make, sorry, I'm going to downgrade one more thing, make a new column. So right now we know that if we just check out surveys, because I haven't really looked at this before, here's some of the information that we have. We have weight, which I think is currently in grams, right? So what if we wanted to do something like convert our weight in grams to weight in kilograms? Is that correct? Weight in kilograms, sure. This might not be a logical conversion, but we would start with our surveys tibble and we would use our pipe. And then we're going to use a new function called mutate, which this will prompt us up. And the arguments that go into mutate, the first one is the name that you want this new column to be. So like I just said, we have our weights in grams, but we want our weights to be in kilograms. This is the name of our new column. And we're going to use the equal sign as an assignment operator here. So at the very start of class, we talked about using the arrow and dash as our assignment operator for objects, not to be confused with this equal sign, because it's within functions that this equal sign, it's what we're going to use as our assignment operator, not to be confused with the arrow and dash. So here we are assigning this new column of weights in kilograms to weight, which is an existing column that we have divided by 1,000. So this is our conversion from weight divided by 1,000 to kilograms. It is telling me that this object doesn't exist because I forgot to add the S, which is also why it didn't prompt and say that weight existed, which was a little confusing to me before. So we are running this line of code, and this is not a great example because the 14 columns, we sort of run out of space. So I will assign this to surveys weight in kilograms. All right, so now we have our surveys weight in kilograms. And what we see is that with the mutate function, we've created this new column, weight underscore kilograms, where we have our value of weight divided by 1,000. And you can sort of look between these two. We have 218 here. We have 0.218 here. So this is the general logic of how we want to manipulate our data to mutate them into new columns. You can make multiple new columns with mutate, as long as they're even within the same argument, as long as they're sort of in a logical order. So for example, if we wanted to do surveys, mutate, and let's say we're going to make let's say we're going to make the same weight in kilograms divided by 1,000, but then let's say we also want to then manipulate this new column name that we've created. So for some reason, if we wanted weight of kilograms times 2, we could take this, and it's already prompted me that we can take this column that I've just created. It actually hasn't even been executed yet, but as long as it follows in this mutate function second, I'm able to make 2 new columns. And again, this is a bad example, or without assigning it, it's bad. But I can make 2 new columns. And now weight kilograms 2 built off of weight kilograms, even though they were in the same function. So it's a pretty, I think, intelligent function for us to be playing with. And it's super helpful because we'll often want to be manipulating or mutating our data, in a lot of different scenarios. We can also combine this with what we've learned for filtering. So like Christian has talked about, select and filter are like bread and butter of subsetting data for me, and I think for a lot of people. And we can also use filter, especially to filter out RNAs, which we talked about a little bit in the challenge. But so for instance, what we've noted, or what we've noticed in sort of these, in a lot of these, is that we have weights that have a lot of NAs, and let's say we didn't want to deal with that. We wanted to get rid of our NAs in our weights. We could use our filter function. So remember, this is removing rows, so subsetting certain rows. And we want to, let's say, remove the weights that have NAs. So this is building off of previous weeks. We know we have this is NA function and weight. And remember, this is saying, right now, this argument is saying, I want to filter out the weight columns where there is an NA. So this is kind of the reverse of what I want. But if I put, remember that logical exclamation point in front of the is NA argument, we are now filtering out to say, I do not want, I want to remove or filter out any NAs in the weight column. So we can run that real quick just to see what that yields. And you'll see now our weight, we don't have any of these red NAs that we had before. And this is really helpful because then we can kind of build on our pipes. Now we have this NA-less data set for weights, so that when we do something like mutate again, our kilograms equals weight 100, we now have, we won't be able to see it, but our last column over here, actually I don't know if this gives, all right, I'm not going to show you that, but now we have our last weight column will also not have any NAs in it. So this is sort of the way that we start thinking about smashing together all of these different functions, and the pipe comes in handy because we're streamlining or piping our functional logic through, like, all together. Okay. Any quick questions about mutate or creating new columns?
I have a quick question. What if you mess up? Can you like alter the columns as they exist once you've done a mutate?
So like you don't want to create a whole new one, but you want to edit a column you've already made?
Yeah, so like for example, in that last line of code, you did weight in kilograms is weight divided by 100. So for example, if you wanted it to be over 1,000, can you alter the column now that it's been executed?
I mean, in a variety of ways. Of course, like one of the benefits of R period is that it's all there, so I can just edit it in kind of the cheating way and go back and rewrite that code. You could remake it. So we also didn't assign this to any object, but let's say surveys, I'm going to call it surveys 100. If I had made that mistake and now surveys 100, which now repeatedly does not have this, but so I've made this mistake and now my weight kilograms is the incorrect number. Yeah, how would I go about doing that? One way that I would think of is just to keep building off of it. So I would take surveys 100. I would probably just mutate it again. Like this would be what I would logic. If I didn't want to go back and change my code, I would take weight in kilograms and now just divide by 10, to get sort of that remainder. And I think that if I run this, it will actually just overwrite. Why is this? I'm gonna see if it overwrites it. I think it will just, instead of creating a new column, I think it will just reassign that value.
Hey, Liza, can you see if your live code as you're going?
Yeah.
So what it actually did is it made a column called weight underscore kg divided by.
Right. So Michael just pointed it out. I was wrong. I sort of expected this to be overwritten, but because I tried to mutate and create a new column with a name that already existed, it actually just took the, although maybe that's because I didn't.
I think it's just because, it's just because you never gave it a new, you never said what you want this.
If I just repeatedly make typos, it will be a problem. If I actually overwrite it appropriately, then the last column would have never existed. So let's run this properly. So I make a mistake. I have an incorrect column value named weight kilograms. And then if I reassign the same name with the mutate function, but I correct it or update it, then we can go back and see that it updates itself. So you can use mutate also to overwrite a column name if you've made a mistake. That was a really good question. Anything else? Okay, cool. We're going to move on to a concept that is similar, but has some important differences, which we're going to call, it follows this general logic of splitting, applying functions, and then combining back together. So this split, apply, combine logic is pretty common in R. Like actually, if you're, very hard to type and talk. If you are Googling around and trying to figure out how to be doing summaries of your data, you will probably come across this idea of apply functions, which are not something we are going to go over today. We're going to go over just the Tidyverse version of that. But it's important that this apply logic is mirrored in the Tidyverse using the two functions that I'm going to show you right now, which are separate, group by and summarize. Tidyverse version, group by and summarize functions. Okay, so what we were doing with mutate was creating a new column that had the same number of rows as our initial tables that we've been working with. But with this split, apply, combine logic, what we're trying to do is create summaries of our data that are combined or organized by some sort of categorical feature. And what I mean by that is it's pretty logical. I think we like to do it, and it's probably the thing that we kind of mess around with in Excel is like summing up different rows and saying, I want to know, say, what are the weights by sex, or what are the hindfoot lengths by plot ID. So we want to know, an average or certain kind of value based on a category in our data. So what's an example of this? If we're back with our surveys data, let's say our first example is that we want to know the mean weight of our sample grouped by sex. So we take our surveys data, and our first argument in this kind of two set of arguments, this group by and summarize, is going to be group by. And this is going to be the variable or the column that we categorically want to separate our data out with. So in this case, it's going to be sex. And I think, like Michael said in the chat, piping across lines is also helpful because you can comment out each line that you pipe. So this is that I want to organize data by category of sex. And then I want to summarize, which is my next function. And summarize, the syntax is really similar to mutate in that you're going to be creating a new variable, at least more often than not. And let's say I want to know the mean weight by sex, but I'm creating this new variable of mean weight with the same logic as before, where mean weight is the new object or value, and I'm assigning it with the equal sign, and I'm going to use our mean function, weight, as our variable. And I'm going to include this na.rm, which we've mentioned in other classes, just because I know that there are NAs that we have not yet filtered out in this data. So what we get back, I'll maybe even just, wrong way, zoom in a little more. What we get back is kind of this much cleaner tibble, right? It's only 3 by 2, and it has summarized for each sex, female, male, and then the NAs that we haven't yet excluded. And then it gives us, it's calculated this mean weight for each group. So this follows the logic group by this category and give me the mean weight per category. So these two functions in sequence are super useful. And this is sort of like the master of making really basic summary statistics. These can be super helpful. And you can play around with this a little bit more. So you can group by multiple columns. So in a similar example, let's say we want to group by sex and species ID. And let's say we want, just to summarize, we're going to use we're going to create the same variable. All right, so executing that, now that we've grouped by 2 different columns, you can see that we have our sex column, but we have each sex repeated, and it will go, there's 82 rows in total. And it's because for each sex, we've repeated each unique species ID. So now we have the mean weight for the species ID BA of females, DM of females, etc. And just one more example is that we can also summarize or create columns of like that are mutated in a variety of ways. So you can also summarize multiple variables. So let's say I'm taking my surveys again. I'm going to do this filter is NA of weight because it's annoying to write the NARM equals true, in my opinion. So I'm getting rid of our NAs with this filter function. Again, I can group by multiple columns, so sex and species ID, for example. I'm getting, okay. And then I will summarize, but in this case, I'm going to create 2 variables that I want to know this summary data about. So let's say max weight, and then I can assign that with the equal sign, max, and then weight. So there's the first summary that I want. And just by separating with a comma, so pretty logical, I can create another column of interest. So let's say in this case, it's minimum weight, assigning it, I want the minimum of weight. And yet again, we have a slightly bigger table that are organized by the same categories, but now we have two different columns, max and min, representing the summary variables that I've asked for. Any quick questions? Like I said, I'm now using this, I'm using the pipe really quickly. I'm kind of showing you what it looks like to sort of be streamlining through these multiple iterations of filtering, grouping by, and then using some sort of summary at the end. So any quick questions on that end?
I have a quick question. So when you're using these pipes, if you're interested in saving this sort of filtering system, would you have to make a new variable? So you'd have to make a new variable and then using the arrow naming it, then use all these pipes?
Like if I wanted to repeat all of this or some portion of this, you mean?
Oh, yes, but so if you were interested in filtering this to use in some other way.
Yeah, so I've not been assigning any of these just because it isn't going to clog up my global environment, and the nice thing about Tidyverse is it will show you this quick output. But I think if I were really trying to manipulate any of this, like with my own data, I would be saving these as new objects because I'd sort of be iteratively building off of them and, you know, naming it like surveys, no NAs, and then from then on using whatever my new object is. So like up here where I did surveys 100, and then I started with surveys 100 in the first line before piping. That is sort of how I would iteratively build on these filters and different arguments. Does that answer your question?
Yeah, definitely. Thank you.
Okay. And I'll show you, I think, just a few more kind of quick examples, things. So like Christian was saying, people will be like, oh, check out, you know, my really elegant data pipe, and people, and sometimes if you go on forums, you'll see lines and lines of codes. It's just one constant pipe, which can be cool. I just want to show you a few more things to, like, you know, tag on a few more useful functions, which one that just comes up for me a lot, and I think actually comes up in your homework, is that let's say you just want to make a table with counts. So we've previously been using summarize to do like max, min, means of things. But if I just wanted to know, for instance, like how many males and females do I have, the count function, which because of the pipe, which is just dragging each of the previous objects forward, I can leave count empty. And if I execute this, then count automatically generates a column called N, and it will just count up the categories that I've asked it to group by. So that's really useful. And then you can also, so count can count, and you can also add on like viewing capabilities. So I'm just gonna snag this last pipe to save myself some time, where sometimes you'll see people put the very last function be something like, so instead of constantly clicking over to see an object or to see a certain length of it, you can say, I want to print it. And if you leave those brackets empty, it will print a default of 10 rows. But you can also assign it to be longer. So say you want to automatically always see 25 rows. If you execute this, then you'll notice that my table output is 25 rows long. So you can play with kind of this last argument to help print with an argument to see more or less of your table without having to maybe assign it to an object or move it around a whole lot. So those are just a few kind of little simple add-ons. And yeah, it's important, I think, we've kind of flown through this idea of mutate, which is making new columns, and summarize, which is also kind of like making new columns. But does anyone want to just give a stab or say like why or how are mutate and summarize different?
Well, with mutate, you're creating a new column, right? You're actually transforming data, and summarize is telling you what's already there, right?
Yeah, I mean, that's an interesting, that's totally true. I'm wondering if you could make a summary column, like technically we could, let's see, I'll grab some of this. I think that we could make a mutated summary column, if that makes sense. So you could probably do summarize and do, oh no, you're right. Because if I just tried to make like weight kilogram,
I mean, I guess I think you probably could, but I guess like summarize is to investigate existing data, but for me, mutate would be to like take your existing data and then get a new metric that you want to be looking at.
Yeah, that's a good summary.
I think a useful way to think about it can be whether you want to operate on the level of every row of your data or across some aggregate.
Yeah.
Right? Do you want to say, I want to calculate calculate something new considering each row of my data as a unique observation? Or do I want to know something about certain groups within my data? So considering all of the rows together where sex is male, or all of the rows together where sex is female. So I think that's the big thing is talking about operating on this aggregate of something else or treating each row as its own unique observation.
Yeah. Yeah, those are both really good summaries. I think sort of at first as you're learning them, it's hard to get a handle on kind of which to use when, but both of these comments have sort of helped clarify that. So real quick, I guess not real quick, we are going to take some time to do a challenge that has 3 parts. And so I'm going to paste it into the chat. It is the challenge that if you're following along in the course material, it's going to be the one that comes after separate. Actually, I will just pull it down into here. So it's this challenge. I think I'm just having a hard time finding my chat. So if someone else could actually paste that in, that would be great. But take 2 minutes to do this by yourself, and Christine will put on a timer, and then we'll send you into breakout rooms to talk through some of this for 5 minutes. So it's kind of playing with the summarize function. So not working. Sorry. uh, cool. So in this challenge, you were asked to sort of play around with a few things. And I'm just gonna see what you all came up with. So the first step in the challenge was to use group by and summarize to find the mean, min, and max hindfoot length for each species using species ID. So does anyone want to talk out the code that they or their group came up with? Maybe someone who hasn't shared yet.
I can try.
Cool. Did someone just volunteer and then?
Sorry about that.
Okay.
I started by typing surveys and then the little pipe function. And then I have filter and then exclamation point is dot NA, hind foot length, and then another little pipe. And so that was just trying to filter for the hind foot length to start.
Mm-hmm.
And then I have group by species ID, and then another little pipe function. And then summarize, and I have max underscore length equals max open parentheses hind foot underscore length, and then comma. And then I have min underscore length equals min open parentheses hind foot underscore length, comma. And then I have average length equals mean open parentheses hind foot underscore length.
All right.
And that's where I was able to get in order to try and find the mean, min and max for the hind foot length for species.
Great. Yeah. So like we said, we said we want to use species ID. So that's what we grouped by here as, you know, one, although there could have been multiple selected categories. And so what this did is it made a column with unique species IDs listed and then did all of the following summary functions in each of these following columns. And we've removed the NAs, which made this a lot easier from the start instead of typing NARM in each one of these lines. So that looks good. The next question was, what was the heaviest animal measured in each year? So you can think about, you know, how would you be able to answer that question using these tools? So what did anyone, and also return the columns year, genus, species ID, and weight. So does anyone have a code they want to share there?
I can share unless someone else wants to go.
Go for it.
Yeah, so I started a pipe with surveys, and then I did the like exclamation filter exclamation point is dot NA weight to try to filter out the values that were NA from the data. And then another pipe, and then I grouped the data by year since it was asking for like the heaviest ones per each year. Then I piped again, and then I did the filter function again with weight and made it something called weight, which I like set equal to the max of weight. So I did.
So you used filter here and then, or?
Yeah.
So you did filter weight equals, sorry, yeah, keep going.
Yeah, I did weight double equals sign equals max weight.
Okay. Cool.
And then I piped again. And then I think and then for the next part, it said in the problem to select for a column. So then I did the select, and it seemed like it wanted year, genus, species ID, and weight to be the columns that get returned. And
and then I did another pipe, and then I did arrange by year. So arrange parenthesis year.
Mm-hmm. All right. Is that the end result?
Yeah, and that's what I got when I ran that.
Okay, great. Yeah, so like Becca said, she also filtered out weights that were cleaned up, grouped by year, because this is sort of the category that we're interested in these summaries, and used filter to just pull out, use our function max weight. So this is a cool kind of combination of using this logical call to say, I just want to bring out the maximum weight in each column that has already been grouped by year, and then use our select function, which is our column subsetting, to pull out just the columns that we're interested in. And then concluded with this arrange function, which is one of these helpful tag-ons that will, I think by default, it looks like arrange by the column that you select in ascending order. So it will start with the lowest year. You can mess around with that a little bit, but so then our end result is what we asked for, and you see just one weight, which we assume is the max weight that was called out in our function. That's great. And we have a third question that I think I'm just going to move on from, because I want to go through one last section today, and the answers are listed. All of these are in our website, which I was realizing I assume everyone has figured this out at this point, but in almost all of these scenarios, there's a little answer drop down, and you can go, check your work, sometimes get an annotated explanation of things, etc. So all of these resources are there for you. Does anyone have any questions on those challenges though, or kind of has some unsettled discomfort with piping, or questions about this logic that we've sort of thrown at you? No. Okay. So just this last concept that I want to put in front of you today is this idea of joins. So we've kind of gone through some of the most common things that we like to do with our data when we first get our hands on it, look at these summaries, calculate, some potentially new columns with the data that we have. But it's also pretty common that not all of your data, at least at first, is stored in one place. Either it was recorded across multiple years, or it's collected from different sources. It isn't all data that you collected, rather you collected some and then you find some from the internet, or it's census data, whatever. There's lots of reasons that you can put data frames together. But the process of this can be painful if you don't know the right tools to use. And so we're gonna put in front of you some of the join functions, also part of the Tidyverse, that are probably the easiest way, I think, to think about joining. Again, like I said, pretty intuitive language, together multiple data frames. I think, like I said, it's sometimes important just to, if you're Googling around, how to combine data frames, you'll also maybe come across merge function, which is in base R. And you might also come across rbind and cbind, which are sort of more like simplistic binding functions. So these are kind of like apply. They're not stuff we're going to go over now, but be fully aware that these are words that will come up in all likelihood if you start Googling around for joining different data frames. But so in order to join together data, we've been working with our surveys data table, but we actually need a second source of data. So we are going to read in one of the other data sources that should already be in your project. And we are going to call it tail, because as you'll see in a second, we're going to use our read_CSV function that we talked about is our Tidyverse version of reading things in. We're going to go into our data folder in our project. And if I tab complete, it will, as I said, show us our options. And I want to read in this tail length CSV. This is a smaller tibble as it's sort of reported in here. I have columns that right now it looks like I have a record ID that is a number and a tail length, which is a double or a number. So I can inspect that a little more. And this is really quick. Can you guys put up green stickies if you were able to get your tail data read in? And I see mostly green. I see one red X, and I think normally if this was the start of class where we were gonna like be using this data the whole time, you know, maybe a TA can help you work with that, but this is more like a intro or teaser for next week, since I know we won't like fully get into this idea of joining. So really you could just follow along and kind of get the general logic of what these functions are doing if you can't get that data read in, or if you don't want to work with it right now. But we have this second data set, and as I've already sort of pointed out, we have these two columns, but we can double check with our call names function. Again, we have record ID and tail length. And where this is similar to our surveys data frame might be pretty clear, but we see that there is a matching column of record ID. So what we're hoping is that these two, I guess, data frames could be merged by some common factor. But it's always maybe a little dangerous to assume that those are the same record IDs. So you could do something like inspect them, potentially by just using the summary function. So we know that our record IDs of our surveys data frame looks a little bit something like this, with a max of 35,000-ish. And if we did the same with our record ID, we'd see that this looks more or less like the same record ID. So that's great. This theoretically is, you know, a variable that we can join based on. And so just to give you kind of the tail end, we're using this whole list of join in Tidyverse functions. And generally how this join logic goes is that you'll give your join function, and then you are going to give your first data frame, second data frame. So I'm not using any clear examples. I'm just kind of pseudo coding this or verbally saying the theory of it, although I can't do this. First data frame, second data frame, and then an argument of by equals, and then the name of shared column, right? And we will jump back into this, I think, at the start of next week. But if you, I'll usually like Google join Tidyverse, and you'll come up with a lot of different websites that will tell you that there are all different types of join. Left, right, full, anti, etc. And they are pretty intimidating at first because it's a long list of here's all these potential ways that you can knit this data together. But I thought I would probably be able to get to at least one example of this before class ended, but I don't want to be that person who keeps you here later than you intend to be. So we're not going to do it. We're just going to sprinkle this in as, you know, your potential future start of class next week. And instead we'll leave the last minute or two. I don't really feel like I need to show you where homework is anymore at this point, but just know if you haven't been reviewing your homework partners, please be doing that. It looks like most of you are keeping up with homework. I think, like we said at the start, we don't have super hard deadlines, but we just are kind of periodically checking in, making sure that the homework from the previous week is generally done around the following class time. And then within a couple days after that, just kind of check on your partner's work, especially as we get into more diverse coding options. And does anyone have any closing comments or questions? As always, if someone could paste in the post-class survey, if that hasn't already happened yet. Already happened. Yeah, any questions? Closing remarks?
Our studio mystery question that could wait until other questions, but if nobody else has one. My question is, what does it mean when RStudio puts a red dot to the left of your line of code?
So I've actually wondered this kind of myself, because you can actually put your own dot over there sometimes, but I actually can't answer that. I know how to remove them. I don't know why they appear.
It means that there's an error on that line, and you can add your own to create what would be called a break in the code. So if you're running some code and you think that there's a problem going on at some point in it, you can add in your own break, and the code will stop running, your script will stop running at that point, so you can like check in and evaluate, okay, what do things look like right here? But yeah, it just means you'll if you hover over it, sometimes it'll give you a little more information about what's going on there. But it will often result if you have a typo, or if you have, like, say, an opening bracket that doesn't have a closed bracket, something like that.
But I feel like there's a difference between the red X and a red dot, which I don't know which one Reed is talking about. But
Yeah.
Oh,
I was
sorry.
talking
Yeah, I
about
guess
the dot, not the X.
dots, I believe, are breakpoints still.
Yeah, so you can put that in on your own just by clicking the number of the line or next to the number of the line.
There. I was doing it in the wrong place. I was like, I thought you could just click, but it wasn't happening. So you have to click on.
It's a blank line. It probably won't.
Wait, and then how do you make them go away?
Just click it again.
You just click on
Click
it again.
Okay. Good.
So I think it's like a flag for yourself.
Yeah.
Is that
I think it will actually stop the script from running at that point. So in the course of running a whole script, I think that's what it's used for.
Mm-hmm. Yeah.
Yeah, it's
for
putting
me,
a break.
Come up, I think, when I accidentally click, and then I'll go back in code and be like, why is there this red dot here? Which it is. I was trying to get a red X or like an error kind of red sign, but I wasn't successful in doing that.
If you make like an unmatched opening bracket, it should give you or like start a closing bracket without an opening one.
You're just too good, Liza. You can do no wrong.
It's really. Okay.
Or Christian, can you clarify the homework again? Are you finishing 4 and then doing 5? There's a question in the chat.
Oh, I think just doing 5.
Pretty much did homework 4 in class.
Yeah, and from now on, the practice of homework 4 of just kind of filtering and selecting will hopefully become second nature in all future homeworks. So, all right, it's 3 after. Feel free to sign off. If you're ready to go, feel free to hang back if you are not ready to go for some reason.
Thank you, everybody.
Thank you.
Thank
you.
Guys.